We are doing 10.4 population density. The very first step is to understand what pop density is. It's the number of persons per mile squared or area. So it's always the population over the area. Do you guys know density in terms of like chemistry or physics or science? What is density equal to? Mm-hmm. D equals M over V. So same idea, the volume being instead area. So we're going to talk about density next unit as well, not just population density. Okay, so let's go ahead and start off. Vermont has the population, so that's the number of people, of 621,760, and its borders can be modeled by the trapezoid with these vertices. We're going to plot those first to start off, where each unit on the coordinate plane represents 1 mile. So once we find the area that takes up that shape, our area is going to be terms of miles squared. Find the approximate population density of Vermont, round to the nearest 10. Okay, let's start off by plotting the points. You guys can go ahead and do that and then verify that I plot it correctly, because sometimes I do not. Okay, so A is at 0, 0. It's going by, is it going by 20 on both? Okay, cool. So 120, 140, 160. There's B. And then 80 looks like there, and 160. And then D is at 40, 0. Okay, so should look something like that. So plot the points, then use a straight edge to draw the trapezoid that is determined by the points. You don't have to draw with a ruler or a straight edge. You can just confidently connect your lines and hope that they're straight. So we have a choice. Because we have the persons, we have the number of people, the population, we want the area so that we can approximate the population density. So to find the area, we can either use the area formula we can split this into a rectangle and a trapezoid or a triangle, or we can just use the trapezoid formula. I personally would rather just use the trapezoid formula. Yeah, okay. Who can tell me what it is? Yep. And then that gets you double it, so you need half. Yeah, divide by 2. Or 1/2 B1 plus B2 times the height. Okay, your bases are the parallel sides. So we've got these two sides are parallel. So because it's orientated by the origin, you just go by the coordinates. So B is up 160. So this height is 160. And my B to C, how far apart are those? 80. Yeah, 80, because C is at 80. And then A to D, that is 40. Yeah. And you can always count the coordinates as well. Okay, cool. So add my two bases, times by the height, divide by 2. Easy peasy lemon squeezy. All right. That's 120 times 160. What did you guys get? Yep, 9,600 or 9,600. Perfect. So our population, once again, is, oh, so let's just write 9,600 right there. Okay. Miles squared. So our population was that number that I underlined at the top. I'm just going to copy it down. So people per area. So we're going to go ahead and divide those bad boys. And be careful when typing the number in your calculator. Especially if you have the one that doesn't show you. If you don't have like a multi-view, it's hard to check your answers. I flashed my answers. Yeah, you're gonna get a decimal. Yeah, 64 point, I get 76, so that does round to be 8. Very cool. That's our answer. The approximate population density is 64.8 persons per mile squared. Do you feel like that's pretty dense or not so dense? Not so dense? Okay. Do you think, compared to Colorado, do you think Vermont's going to be more dense or less dense? Less dense? You think Colorado's going to be more dense? Okay, let's see. We're going to do the same thing, but this one is, the population is very big. I think Colorado is pretty big as well. Its border can be modeled by the rectangle with the vertices here, and where each unit represents a mile. Again, find the approximate density of Colorado, round to the nearest tenth again. Okay, cool. So rectangles, just a heads up, I will give you and you'll be provided with the drawing. Okay, so you won't ever have to like do all of the work, because today we're doing like all of the work for these problems. Most of the time you'll be given the model. Okay, negative 190, I'm going to put that right here. You can be technical about it, but I'm just going to be loosey-goosey with it. So I see I'm at negative 190, 0, and then positive 190, 0. That's A and D. And then negative 190 and 280. So let's put 280 up here. And it does not have to be drawn to scale. But because it's a rectangle, I know it's going to look something like that. Let's double check and make sure I did that right. So B is at negative 190, 280. That's B. And then C is at 190, 280. Okay. I don't think I drew it nicely. I think I think my scale is off. So if you went like by, oh gosh, what could you go by? I want to say tens, but tens is kind of annoying. You'd have to go like 19 and then 28. Yeah. So just doing like this kind of gives you the right idea. And it should tell you what the shape is so that you have a good idea of what it should look like. So we're going to do the same idea. We start with our population density. So we're going to take 5,024,748 and we're going to divide it by the area, which we're going to find. And that's going to get us our population density. So the area formula for a rectangle, it's just a fancy parallelogram. What's that formula? Length times width, base times height. Yeah, both are correct. Okay. What's my base? Yeah, 190 plus 190 gets you 380. So our base is 380, and then our height is just 280. Yep. Don't divide it by 2. What do you get? I didn't do it yet. Yep. Yep. 106,400. You guys said it correctly. Okay. 106,400. Go ahead and divide that 5 million number. It's a very specific population. They didn't like round or anything. They said there's this many, specifically 748 people in Colorado. Okay. Yeah, 47.2. So it ended up being less dense, even though the number was a lot bigger. My assumption, I mean, what's the size of Vermont? Vermont is pretty tiny, whereas Colorado, I don't know, is it bigger than Florida? I think so too. Okay. What do you think about Florida? Would we be more dense than these two? Yeah, definitely. Does our population density stay consistent year round? No. When do you think we're most dense? Summer? Really? Okay. Yeah, my other class, second period also said summer. And I'm like, I think there's like a good 6 month period from maybe like November to March. Yeah, spring break, they probably a lot of it's the snowbird season. Everyone comes. Okay, the last question is kind of backwards. So for the maximum grain yield, corn should be planted at the density. So this is my answer: 38,000 plants per acre. So my units are changing a little bit, but this one takes me through everything. So a farmer has a field in the shape of a quad with the vertices, yada, 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 where each unit of the coordinate plane represents 1 foot. So we're going to have to convert. So looking at the steps, what is the area? We can do that. We just did it right here. We might have to split it up into shapes since it says it's a quad, but it could be like a nice quadrilateral. And then what is the area to the nearest hundredth of an acre? And it tells me the conversion. And then figure out how many corn plants. So that's like our population. So we're going to go backwards. We'll just plug it into the formula and go from there. So take a moment to plot the shape. Do you want me to spoil it for you and tell you what shape it is? It's a trapezoid. So it works out nicely. It's a trap. Okay, so 0, 0 is J. And then I'm going to go 0, 400 and just call this 400. I think you could go by hundreds, actually, if you wanted to scale it. I'm going to be lazy and just go by there. And then 500 is down here. And 600 is up here. So there's L. I tried to scale it. Oh, it looks okay. And then 500, 0 is M. So it's a nice shape. It's not anything too crazy. It's a sideways trapezoid. I kind of love trapezoids on the coordinate plane because normally it's hard to figure out the height, but you can always like do a perpendicular from the two bases and that gets you the height. So it's actually quite easy to find the height in these, even if it wasn't like this shape. Okay, I'm thinking about this problem. Why didn't he just make his cornfield in the shape of a rectangle or a square? kind of weird farmer. Okay. I shouldn't judge. I'm not a farmer. That's true. He could have other crops around him. Okay. What is the area to the nearest square foot? Okay. The bases are here. So let's go ahead and find our bases and our height. So the KJ, what's that base? 400. And then LM, 600. Yep, 600. So we're going to add the two bases, 400 plus 600. And then our height is in between them. That would be 500. Very good. And then divided by 2. So I'm going to write the formula just to remind us. I can't remember. Did I give you the formula on the formula sheet for trapezoid? No. Dang it. I was hoping that you didn't have to remember all of the formulas. But you don't, but it's a good chunk. Okay. I got quite a large number. Yeah. 250,000. And that's feet squared. This color is not great. Let's finish it and then use the black again. Okay, so how do I get acres? 1 acre is equal to that many feet, 43,560. So am I multiplying by that number or am dividing? I am dividing. The way I remember it is what you want goes on top. So 1 acre goes on top. And then in the denominator goes what I'm trying to get rid of. I'm trying to get rid of the feet. So you divide by that. So I still have 250,000 in my calculator. I'm just going to divide by 43560. Okay. What did you guys get? Yeah, so 3.9, that would round up to 4, right? Okay, so 5.74. Okay, acres. And now we just, I was going to say we just divide by the number of acres, but that's not correct. So we have plants per acre. So we want the number of plants over how many acres we have. So what operation do we do to get the number of plants? Multiply. Since it told me what to round to, I'm going to use my rounded answer. Normally I wouldn't. And then I think this one tells us to round to something weird. Okay. So I'm going to read it now. Approximately how many corn should be planted in the field for maximum grain yield? Round to the nearest 10,000. So did you guys get your answer? No, not yet. Yeah. That's what I got. Oh, you can't see it. Okay. That's what I got. So to round to the nearest 10,000, so 100 place, 1,000, 10,000. Is that closer to 21,000 or 22,000? 20, I'm saying it wrong. So 220,000 is correct. I need to go back to, what grade is it where we practice how to say the places? Third. I remember having, it might have been my weird teacher. I had a very Russian teacher in 7th grade and then in 9th grade. So I think I learned it in like pre-algebra, and then I had her again in algebra 2 because I skipped algebra 1. Did I skip algebra 1? No. I don't know. It was a long time ago. It was in Alaska. Okay. Any questions on this? Cool. That's a lot of corn.